Please join me in welcoming Jolyn Russell.
Thank you so much for the kind words and for inviting me back to campus. It's been a long time since I've been back, so it's really exciting to be here. It's probably been since 2005, so seeing that the campus is still thriving and to see this great group here is really exciting. First and foremost, though, congratulations. You guys did it. It's probably feels like it's a long time coming. It's a big deal. It really is. You kind of joined a club now, and this place takes some true tenacity to get through. And not that often in the Washington, D.C. area do I find a fellow Michigan Tech grad, but when you do, there's an instant connection, and now you'll have that with all the people that have come before you and all your classmates here right now. For each of you, this past years have been filled with some different kinds of challenges, right? Some people maybe love dynamics and hated statics or some combination thereof, but you figured out how to get through all that, right? And I hope that you learned how to work with your fellow classmates and figure out each other's strengths and weaknesses, because that's really where you're gonna thrive in the long term. And for me, I got out of here 5 years later. In some cases, I finally realized, oh, that's why they were teaching me this. It seems like the curriculum now and the projects that I saw you guys presenting today, you're really, they're starting to tie that more together for you. So I hope you really get out there and you've already got some more practical knowledge, and that's gonna serve you really, really well. So, the thing that we're here for today is the Order of the Engineer, and it's got a couple pieces with that. It's an obligation to protect public health, safety, and welfare, and that all the members of the engineering profession share a common bond. We're all in this together. You guys, the fresh outs, as we at NASA lovingly call you, and those of us who have been in the career for a long time, we all have that. We all have that in common. Trying to figure out what I was going to talk to you about today was kind of an interesting thought exercise for me. I spend a lot of time with slides like this, talking about my experience summary, kind of summing up how I got to where I am, talking about the Restore-L mission, where we're trying to take a satellite with a couple robot arms and go grapple something in space and birth it and refuel it and figure out how to have those technologies for more deep space exploration. I know how to do that. I know how to give tours of the lab that we work in, where we try to prove out all this technology, where I get to work with a great group of people every day. We take ethics training at work, right? They have they have quizzes at the end that are multiple choice and true and false, and are you allowed to accept gifts greater than $25? Am I as a contractor allowed to drive a civil servant? There's all kinds of nuanced rules and things, and we have to follow those. But for me, ethics is really about what do I expect from my colleagues and what do I owe them every single day when I show up at work. So for me, it kind of comes down to a couple different things as I went through this thought exercise over the last couple weeks. It's really appreciating different perspectives, listening, really, really listening. Being okay with being wrong sometimes, and not with negligent ways, but we're gonna make mistakes. You're gonna go down a path that made sense with the data that you had at the time. Your colleagues are gonna do the same. Don't be judgmental. We're all gonna make mistakes, but we all have to fix it together. Think about the long term. What you're doing as an engineer actually has an impact. We actually get that privilege of impacting. We really do impact the health and welfare of the people that we work with. When I'm working on weather satellites, we're really focused on hurricane prediction and saving people's lives, right? We work on people go out into automotive, and we care about the safety of the people that we work with. And then really it just comes down to being humble and simply being honest and fair. So understanding different perspectives. This actually brought me back to the meme. Back before you guys can imagine, we'd line up with these paper pamphlets trying to find our classes and pick our schedule, and you were in this line, and there were computer terminals and people with flags, and you're trying to get the class that you wanted so you could graduate when you wanted. There's a screen that's telling you your class is full. You're trying to race to the front, hoping the person that's typing in your classes is typing faster than the person next to you. It was really stressful. I'm sure you still have these issues now, but it was, I was standing there, I'm like, who doesn't have to do this? So the athletes didn't have to do this. So I wasn't gonna become athletic. That was clearly not gonna happen. But there was one other out to early scheduling, and it was being a coach at the Engineering Learning Center. And I'm like, oh, I think I could do that. I actually don't even care if they pay me, but if I can schedule early, this could be a good thing. So it turns out that I got that job. I actually interviewed with Dr. Pradhaban back in 1995. And that turned out to be such an excellent experience for me. People would come in and you'd see how other people thought about problems. I think this is something that as students we don't often get, that professors get, but you can see how other people go about a problem in a different way. And if you can teach a double E how to do statics, you've taken on a different mindset and you've accepted that there's a lot of different ways to solve a problem. And I go back to that a lot and listening to dealing with people, managing people, knowing that there's different ways to solve a problem. The next thing is being okay with being wrong. Engineering is hard. We're trying to do things that have never been done before. When I was in grad school, I had a quote above my desk that said, if we already knew the answer, we wouldn't be doing it, right? And that kind of guides you, that we're trying to figure out something that hasn't been done before. So Raven, an experiment that I had the pleasure of working on, is up there in the left-hand corner. Our division took an opportunity to work with STPH-5, which is an Air Force group, and so we built our part of the instrument, and we had to go and make it fit on top of a bunker down with the guys at JSC. We actually did that right down the hall from where like the Apollo control station was, so it was really cool to be in that historic setting where mistakes have happened in the past, right? So we went to this, we knew that the base plate might be bowed, we had shims, we had extra fasteners, we had everything that we could think of. We were ready for this, it was gonna be great, we're gonna be there for 2 days and come home. And we get down there and 0.06 inches, we were off and we could not put that thing together. And it was a terrible, terrible day. It was like, Houston, we have a problem, not at the level that they had, but it was really, so the finger pointing could have started. It could have been, you guys did this, we did that, whatever. But we all kind of rallied together, and we figured out how to solve that problem. And it ended up being that some of the greatest techs I know were actually drilling a new hole close to an optical instrument, as you can see laying on the floor, we rigged up something, and it worked, right? And we all worked together. And now you can see a picture at the right there of STPH-5, a collaborative effort on space station getting moved out to our place in space, right? So we could have, and now those guys in Houston, like, we've got each other's back forever, right? They're already like, when is H6 gonna happen? How are you guys gonna support us? So doing the right thing, we're all in it together. Now, if the guys working on the launch rocket that day had had their bad day, I might be here telling you a different story. But fortunately, we made it to space. So the next thing I wanted to kind of hit on was just thinking long term. Sometimes it's easy to go for the short-term solution. The great thing about undergrad in some ways is, right, the semester ends. You get to eventually get the grade and walk away. For some of you, it probably seems like your capstone design project was never going to end, but someday you're going to be past that and you're going to move on and you get to go on to the next big thing. But once I got to Ford, that was the first time in my career that you really realize that what you're doing is out there on the road for a really long time. So I was working on the E-Series vans, and we were trying to implement getting roll stability control on there. So you can see up on the right, we had like just a little bit of package space, and we're trying to put this whole new system in there, and we had to fit these really big hoses under the hood. And we had to figure out how to do this and have it all fit, and they could rub together. We were worried about a lot of things, and if those things rubbed together and wore out and brake fluid went everywhere, that's like someone not stopping their vehicle. Like, that's a real thing, right? So we did all the testing, we did all the engineering, we did everything we could to do the right thing. But to this day, 15 years later, when I see an E-Series van in the parking lot, it takes everything in my power to not go ask the person if I can pop the hood, see how that's working out for them. So I think my husband's glad that those are just about all off the road. But yeah, that really has impacted me to this day, that the decisions that we make, they really have long-term effects. And had we cut corners and not done the right thing, I think I'd look at that in a whole different way versus how I'm able to now. It was really cool to work in vehicle safety and feel like you were really impacting people's lives. So then just to sum it all up, be humble, honest, and fair. We need to be objective in your decisions and the data that you present. All too often, we criticize managers, we criticize people making decisions, but you're presenting that data to them. It's the integrity of everybody coming together and allowing the right choice. I'm surprised how often we actually do see emotional engineering happening, where someone's got this gut feel and they want to go down that path. But we really have to step back, be objective, look at the system view. And let's face it, engineers, we can be really, really arrogant. Sometimes I wonder, is it the people that think they can solve all the problems if they have infinite time and money that go into engineering, or is it that we come through this curriculum and we decide like we really can do this and we're overly confident? I don't know the answer, but you got to figure out how to bring it back and be humble. For me, that's getting out into the mountains. It's getting out into the big, big ocean and kind of getting your place in the world and realizing where you fit in. The thing that's really done that for me is aerospace engineering. It's really an honor to work in this field. I mean, space is huge. The opportunities for exploration are just really, really endless. And the perspective that we get at Earth from space is just kind of this mind-blowing thing when you see images from stuff that you worked on. So that's been something that really has put me in my place, trying to figure out how to work with things on the ground, simulating a zero-G environment, understanding how we have to do things in vacuum and how all of those things play together is a really humbling thing, and it makes you change your mindset and think about things in a whole new way. We talked in the introduction, Bill talked about the filter redesign. We were trying to look at the sun on GOES 14. That filter was successful, and these are some of the first images that we had from that. The mission we're working on now, my division chief is always talking about how we're going to change the world with how we do space. And you know, he really believes that, and it's really inspiring, and I hope we do that. So that's the mission we're working on there, Restore L. This is one of my favorite pictures of Raven with the solar arrays of ISS in the background, and then the visible image there is one of the first images that we took of SpaceX docked on station and looking back at Earth from the sensors that we worked on. So those things continue to inspire me. And then my whole family got to go see the launch with me. So we're like hanging out at the vehicle assembly building, and it's like tailgating before a launch. People are throwing footballs around, you know, everybody's brought their breakfast food, just hanging out picnic style. And but yeah, don't forget your family. Don't get so caught up in your career that you lose sight of the stuff that really, really matters. Having them there with you and supporting you through all that is the best thing you can have. So work's important, but life's really, really important too. So yeah, we're all in this together. We got to make it work. We got to do the right things. It's kind of my quick glimpse at the world, but thank you so much for your attention. I wish you all the best. I hope you can find passion in your career. It's really a good career. You found a great spot, and you're surrounded by a lot of great people. Network with the people that you have, and stick with them for a long time. And I wish you all the best.